Welcome to Click My Project.
Security as a service model for cloud environment. Abstract. Cloud computing is an important technology that provides services to the users. The cloud provides infrastructure, platform, and software as a service. The infrastructure service provided by the cloud is used for storage purpose. The term tenant to refer to cloud customers who wish to access service for cloud providers. Tenants can themselves be using their virtual machines to provide services to their own customers. The tenants in the cloud can run different operating systems and applications in their virtual machines. The vulnerabilities in operating system and applications can be potentially exploited by an attacker. The attackers generate different types of attacks. These attacks can be targeted against the cloud infrastructure as well as against another virtual machines. There is a need to design security architecture and develop techniques for securing its infrastructure. Modified data security model enhancement in cloud environment. Abstract. Cloud computing is one of the most emerging technologies which plays an important role in the next generations. In the cloud computing system, both application software and databases are moved to the large data centers. In the data centers, that data should not be secure in the hands of providers. Cloud computing security concerns, especially data security and privacy protection issues. The baseline security is needed by the provider to ensure that malicious tenants are not attacking the cloud infrastructure. Every tenant has to have the security functionalities that forms part of the security baseline. Security architecture that provides a flexible security as a service model that a cloud provider can offer to its tenants. The trade-off between the security and privacy should be managed. Proposed system. The proposed system contribution is a security architecture that provides a flexible security as a service model. The proposed system concentrated against different types of attacks. The proposed system maintains a trade-off between the security and privacy. The proposed system describes an enhancement for the already existing data security model in cloud environment. The proposed data security model provides user authentications and data protection. The data are stored without compressions in the cloud, which lead to large space utilization. The authentication is provided at the time data storage alone. The controller will control node for only entry and the cloud controller and the storage controller does the authentications. The data is stored in non-encryption form that lead to access of the data by the unauthorized user easily. Existing system. In the existing system, the operating system and applications of the tenants can be potentially large and complex. The existing system contains security vulnerabilities. In the existing system, the cloud service providers do not generally offer security as a service to the tenants. Tenants need to make their own arrangements for securing the virtual machines that are hosted in the cloud. There are several significant challenges in securing cloud infrastructures from different types of attacks. Disadvantages. In the existing system, the data stored in the cloud does not have privacy. In the existing system, the data which ever stored in the provider hand may not be fully trustworthy. In the existing system, the load of users can be decreased to some extent. In the existing system, every tenant can view and access the data of any other tenants. Advantages. The data are stored after compressions in the cloud that leads to less space utilization. The data storage is allowed only after the IP verifications of the user is authorized. The authentication is included at the time of node creations rather than storage and retrieval of data. The node controller control capability is extended to provide services to a large number of users with a single link. The storage controller first compresses the data before storing the data into the cloud. The data can be retrieved by the user after the IP address verification. Data flow. First store the data. The number of nodes to control the node controller, and the node controller moves to cluster controller. Then the cluster controller moves to storage controller. It's on data compressions. In storage controller and goes to authentication. Then ID initialization. Then it moves to cloud storage. Then again it moves to retrieval of data. Node 1 and node control, that is a request for retrieving data, and it moves to ID verifications, that means authorized ID. If authorized ID is correct means it goes to access granted. If the ID is wrong means it goes to unable to access. And finally we are going to get retrieval of data. From here I am going to run the project. Now I'm going to browsing the data set. From the data set I'm going to get, then the data to be successfully viewed, then I'm getting the original file size, then again I'm getting the same data, data set.csv. Again now I'm browsing completed. Then now I'm getting the data compressing the data size compression completed. Then compression size I'm going to get here. Then key generations completed. Again I'm going to store the data. Now I'm getting any one of the data, browsing the data. Then I'm going to store to again another processor. Here now I'm going to split 13 size of the data. The file has been stored successfully. Here I'm going to run the process SGS. It also run to the console. First I'm creating the number of users. Here I'm giving the 5 users to be created. These are created successfully, and user 1 generate random key, and the random key also generated here. The random key sent to user 2. The user 2 receives the random key, and now I'm going to browse the data. Here I'm getting the data successfully. Data is browsed. Then user 1 I'm in the colon. User 1 I'm having the user 1. Here I'm having some data. Then I'm having open the data. User 2 data stored successfully. The data is to be stored in user 2. Here the number of sub-users. I'm giving sub-user 2 sub-user. Sub-user get it successfully. Then here I'm getting the number of sub-users. Sub-user 1 I'm getting sub-user 1 sends request to sub-user 2. Then here I'm entering the number 1 2 3. Then login successful, and the user 2 accept the request. Then user 1 recommend some keys, and here user 2 also in the colon. User 2 having the data. Now I'm giving the values. Now I'm clicking the login successful. User 2 accept the request. Here values created in the colon. User 2 also having some data. I'm opening the data here. The data to be stored in E colon. Now I'm going to open the E colon user 1. Here the data is to be stored here. Storage of file 1 like that. Here the data is to be stored in D colon data. Here the E colon to be stored.